Now, let me quickly give you a tour on the challenges that we get with respect to machine learning model deployments. Scalability. This is one of the first challenges that we will have. The second challenge is the drift. It could be data drift, or it could be the model drift itself. Of course, model drift occurs because of the drift in the data, change in the data fields itself. And of course, you'll have additional challenges like the security, the monitoring. Monitoring basically is covering this aspect. The connectivity with various sources, and with respect to the hardware management, you'll have scalability, scale up or scale down issues. Predominantly, managing the deployment would become very difficult with respect to these specific challenges, right? So I would probably brief that into two issues. One is the server level management, right? Scalability is basically addressing the is addressed here. Server level management, infrastructure level management. The next one is monitoring and maintenance with respect to your machine learning model. Right? This is with respect to machine learning model. Same maintenance, monitoring and maintenance is with respect to hardware that is addressed in scalability, and the drift of model is available addressed in this right aspect of monitoring and maintenance. ML code is very small, right? That is very small aspect in the entire, I should say, the technical depth that is required for deploying a machine learning model. So here we are going to try and look at various readily available platforms which can help us develop a machine learning model with machine learning operations standards, with MLOps standards. And one of these solutions that we have is with respect to Azure, which is a Microsoft cloud platform, Microsoft Azure platform. And here we will have many services which can allow us to deploy a solution in production environment for scalability and right, monitoring aspects considered. One of that is AutoML service that we have in Azure. So if I have to talk about that, it is, let me come back to the containerization. Yeah, Azure Machine Learning Services. Here we will have Azure Machine Learning Studio. This is more like SageMaker, which is very popular service from AWS, which is a graphical user interface, which provides a lot of services for us to manage. In fact, I should say, develop, train, evaluate, that is your testing and deployment of machine learning model development, end-to-end ML development. Everything is graphically done. Graphical user interface is provided. You don't have to write much code. In fact, zero code. Right? So machine learning, Azure Machine Learning basically is a service which allows us to implement machine learning models with respect to MLOps strategies. So we will be training and deploying the models. And of course, we are also managing these models by following the MLOps strategies. Right? You can also use a locally trained model, which we will be doing that now, of course. And or we can also deploy or develop the solution directly from the services that are provided in AutoML Studio. So that means it can work on both ways. You can develop end-to-end everything using the service, or you can use a readily available model which is locally trained for deploying that on the studio or maintaining that model on the studio services. It will also allow us to very easily monitor because of the graphical user interface options that we have. Even non-machine learning developer, right? A resource, a person who's not familiar with machine learning standards can also try and monitor, retrain if required, and redeploy the models that are developed for machine learning. Right? So everything can be done. And these Azure ML tools, they follow by default, as I mentioned, machine learning operations. So you don't need to be a domain expert. You don't need to be a machine learning expert to use this studio, ML studio. Right? Everything is very simply done, and you can directly take your model to the production, and that too with security implemented. Right? So we basically summarize it saying that we can train, right? We can test, we can deploy the machine learning models easily and very quickly, and we can manage and govern the models, right? With single click of these buttons. All right. And all the compliances, security norms, everything is readily available in the studio, which is automatically implemented when you're developing your machine learning models. But as I said, we are not looking into this, okay? What we are going to do is we are going to deploy a model via containers. And those containers are basically created in the container registry of Azure. Right? Azure has container registry, which is like your Docker. And to manage, to implement these containers, the images that we are creating, right? These containers will be deployed using the AKS service. This is Kubernetes, this is AKS. Kubernetes is a open source, so that Kubernetes service is implemented in Azure so that automatical management of the entire resources be done using the service itself. As a user, you don't have to really worry about maintaining or managing these clusters that you're going to use for your deployment. So AKS is one of the quickest ways for deploying your applications, right? Everything on cloud. Okay, so that is the advantage, one of the quickest solutions. And it is a single tool, right? It is a unified management and governance tool for on-premises implementation, edge point creations, and you can also scale up or scale down using multi-cloud Kubernetes clusters. So hybrid clusters can also be created. We're not going into the hybrid clusters, of course, we'll be sticking to our Azure clusters only. But AKS has that capability. Right? And as I said, this is the quickest way to spin up a cluster so that we can streamline the deployment of your machine learning model on pre-built cluster configurations. And these are managed by Kubernetes services of Azure. And everything is automated here as well. Automated, automatic integration of these CI/CD pipelines is there. And these things can basically use code repositories like GitHub and GitHub Actions, of course, so that any changes that we are making to our code can basically be pushed to your end user. Right? So CI/CD pipelines are implemented. And this way, any changes that we are making, any updates that we are making to machine learning models will automatically be reflecting in the end user's perspective. And AKS provides flexible development options. Right? As you will see, there are a bunch of commands that we do. You can also run it from the UI. That also I will show. And we can use any OS. Okay. So on-premise implementations can be done. So on-premise implementation of AKS on supported customer managed infrastructure. So you can integrate your Azure AKS services with cluster managed infrastructures as well. That is what we talk about, multi-cloud infrastructures, right? So hybrid infrastructures can be, hybrid options can be implemented in AKS. We can deploy the containerized images, or basically you're talking about containers, which could be from Windows or Linux, right? OS independent. Containers obviously are OS independent because they have all the prerequisites which are required for application to run. So this AKS is also helping us to do that. So it's not different, friends. Whatever we discussed with respect to Docker, right? We discussed about creating a Docker image and then running this Docker image to right, create a container, containerize it, so that that container can be used as an instance, right? End results. But the problem is Docker is a service which is manual. So managing your containers, trying to right, work with multiple containers becomes really tricky because everything is manual there. So we have Kubernetes services which basically are used for managing these Docker images or Docker containers. Right? So for Kubernetes, again, you need to have the hardware because ultimately it has to require the resources for containerizing the services or right, deploying these images to get a runtime instance. So the point is, we basically have images. And to manage these images, we will be using Kubernetes. But these Kubernetes services are running on Azure platform. Right? So this is the hierarchy you can look at. So AKS is basically a self-managed tool. Auto management of all your cluster servers are managed to create runtime instances for these images. That's the simple way to put it. So let us now try and implement it. Okay, so you already know what those containers are. We discussed about those containers, Docker images and all that. So containers are nothing but a single standard unit of software which try to package everything for an application to run. It could be runtime implementations, cross functionalities, OS level library dependencies, right? All those dependencies are packed together. And that gives us an application. Right? You can create multiple images and each image can then be created. Runtime instances can be created. So that, right, from the same image, you can have multiple applications. Now, for an end application to run, whatever the dependencies, libraries that are required, binaries that are required, they are packaged together. And that's the reason why we call it as an image. Once I have an image, I can create multiple runtime instances using multiple containers. And these containers will be independent entities which can be working or which can be running on the single hardware. And all of this hardware will have single operating system. All we need to have is this Docker software, Docker engine. Right? And this Docker engine is going to convert these containers as an individual entities. Okay, so that's basically the concept of containerization. And the main point is you don't want dependencies, right? Prerequisite dependencies or OS level dependencies to hamper your application when you're trying to run that application in different systems, right? So that's the concept of Dockerization. And these are the commands with respect to Docker. So let us try and work with the entire implementation hands-on. First, open a command prompt and I will say Docker images. I don't have any images, right? So first I need to go to my Docker file. So these are the bunch of files that you will see. Model is nothing but your pickle file, saved model. Requirements.txt contains all the dependencies list. It could be the packages, it could be OS required libraries, everything. And this is your script for your model. It contains, you can basically talk about Flask. If I talk about Flask API, this is basically a script which initiates the UI for your model. And then to implement this on the AKS Kubernetes services, we need this YAML file. I'll talk about the YAML file. So these are a bunch of the files that we will have for our deployment to work. And Docker file basically also is required for having the initialization of your Docker image. So this is placed in this folder, right? This is the file I have. I have a couple of YAML files. You can ignore multiple YAML files. I'll take only one YAML file. So I have saved pipelines. You can see this pickle file. This is joblib file. This is requirements.txt, where I have mentioned all the libraries that I require for my application to work. App.py is basically the file for Flask API, right? And this is an file where we will basically have the commands that we need to run now. You don't need to put this file in the same folder. Just for ensuring that everything is in one place, I place the file there. And we have Docker file as well for creating the Docker image. So this is the syntax. We are giving the details from Python. So this is the library that we are using. I mean, software that we will be using from Python. This is the version. This is the image. We are exposing the application, the container to port 80. The working directory will be flask/docker. It will get created internally. And these files will be copied, right? Requirements.txt will be copied into this working directory. And then we will be running the libraries into that particular environment. Copy everything, and then we will try and trigger the application. And we are allowing the access to that particular application from all these different hosts. So you can basically access it from any host, right? We're not restricting the host application. So this is your Docker file. And let us try and also open Docker desktop. If you have already installed Docker desktop, you can basically open and see if there are any containers or images or volumes, right? So nothing is there. So let us try and create a Docker image. And for creating a Docker image, we will use this strategy. First, I will have to go to the folder where my software is located. So I'll just copy this. I will say CD and the folder name. So we are inside that folder working directory now. I will say Docker images to see if I have any images. I don't have any images. So to create an image, we basically use this command, build command. I will say Docker build -t. You can give any name. That's your choice. Right? We can create cars. You can say car2, because that's something that I've used in my presentations as well. So we are going to first deploy our Docker image, right? Docker build -t, the Docker image name, and then I would say -f docker dot. So it's basically now creating the entire Docker image. You can say Docker images now. So you will see the Docker image created. You can also open this and check here, your Docker images created. Now for creating a runtime instance, we will again use the run command. I will say Docker run. You give the port number, right? And then we will try to push the image. Okay, so this is basically your image. I will say car2. So we are running the Docker image, and this is the URL that basically is given to us. So I will just open a new instance. So I get the deployed application, and I'm just loading new file. And then when I click submit, it gives me the result. Okay, this MPG is the final output that we're interested in. So this is the prediction that we're getting. All right. So this is how your application should work. So let us keep this aside. So this is Docker image, and you can see the container is also up and running now. Okay, you can, yeah. So Docker container is up and running. Okay, you can also see this link from the desktop, and this is what we have observed. Now comes our Azure implementation. Now the Azure implementation can be done using two techniques. One is directly you can log in, and right from portal.azure.com, you can create your resource groups and all that. Using the portal, we will be able to do this, or we can also do it from Azure command line interface by selecting it as application and by connecting to the Azure CLI, or we can also try and install this Azure CLI application. All you need to do is search. You can basically say Azure CLI for Windows, right? Install the Azure CLI for Windows, install or update. This is Microsoft installer, latest release of Azure CLI. If you click on that, you would get the software downloaded. This is what you will get. If you double click that, it will try and install. All right, so this is just click next, and your installation will be completed. My installation is already done. Okay, I already have this installation ready. Okay, so what we do is we will open another command line. I'll not disturb that. I'll open another command prompt. And here I say AZ login. AZ is Azure. I'll say AZ login. It will redirect me to this page. It will, if it is not already given, if it is not already logged in, it will ask you for login. And it is already logged in now. Okay, so I have the access to Azure services from CLI. Okay, That's all. You basically say az.login. It will open up your browser and it will ask you to log in using your credentials, and you'll be able to log into your Azure platform. So this is the CLI that I'm going to use now. And there are a bunch of steps that we will have to perform. So the first thing is if you have to deploy the model via containerization through Azure Kubernetes Services, then these are the series of steps that you'll have to do. We'll first have to create resource group. Any Azure application that you want to work with will require us to create a resource group first. And within this group, right, this is like a project that we are creating. Any resource that we are going to consume from Azure to work with for this project will be assigned inside this group itself. It will be mapped to this particular group. So it's like creating a group ID. Then once the group ID is created, we would be initiating the container registry. Container registry is like your hub, image hub. So any images that you have, Docker images that you're having, we are going to create a runtime instance using this container registry. We're registering our image here. So we will map the local Docker image. You have a local Docker image, right? We will map that to this Azure container registry. We will get credentials, so we will map using these credentials. And from here, we will be able to push that onto your AKS. So we'll create a container here, push the image so that we get a container, and that container will be implemented or managed using AKS clusters. Okay, and here we will have pods and services. These pods and services will be given or created thanks to the YAML file that we will have. YAML file is like a script. You can say it's like a script which instructs what all services we need on the AKS services. So using kubectl command, which is a Kubernetes command, we will try and apply all these sequence of steps which are there instructed in YAML, which basically takes the Docker image and creates a container which is managed by Kubernetes Service. So the first step is to create resource group. So I will be using these steps. The first step is this one. So here, I'll be running this. I'm creating a resource group. Okay, the resource group is cars MLR. Okay, resource group is created. Now, these resource groups can be created directly from here. You can see resource groups option from the portal. You can also click on this. So when you say resource group, this resource group is created from our backend. You can also click on this plus symbol from a UI perspective. You can say click, give the resource group name, review and create, and then basically create the resource group. So this way also we can try and do. Once the resource group is created, then we are going to try and create the container registry. So this is the sequence of steps that we'll have to use. My container registry, the resource group is this. My container registry is also having the same name. Okay. So again, I'll try and run this. Done. ACR is Azure Container Registry. If you want this container registry, you can always search here. Okay, and you'll get your container registers. You can click on that. I'll refresh. It's not created yet. Oh. Invalid resource name. This resource name invalid. This is what we created, right? Create resource group is created. Did I do any wrong command? Yeah, resource group is created. Then resource registry is created. Okay. Did I do the wrong name? So registry name is even wrong there. Right, so let us change that. Container registry. We are creating a container registry called cars SVM and yeah, standard SKU. You can also click on create container registry here and then give the names here. Okay, so this way also we can try and do it. I would want to stick to this. So I'll take this so that there is no confusion. All right. So we are sticking to this registry. Okay, and here you can see there are many options. By default, it's standard. We can also use basic. Okay, so this way you can also give the SKU. SKU basically provides the capabilities, right? That means your units, registry units, what kind of scalability, all those things will be depending on which SKU you are basically choosing. All right. So you can, by default, it is standard. You can also give the basic SKU, okay, like this. So I'll take this and I will, oops, my bad. Yeah, so this name was given same name, so that's the issue. All right, registry is being now created. Once this registry is created, we are going to work with your Kubernetes cluster now. So the next step would be, after registry is, we are going to work with your Kubernetes service, Azure Kubernetes Service. All right, but before that, before we create the Azure Kubernetes Service, there are certain small steps that we need to do. For example, here we need to record the registry keys. Okay, how is that done? Let me show you. Yeah, this is created. All right. Now, once this is done, you can also check the registry here. If I do research, the refresh, you'll see this. Resource group is this, container registry name is this. And when I click on that, it will take us to this page. And here, we need to click on this access keys. Okay, networking, of course, is there. We'll not change it. Okay, basically. SKUs are basically allowing you to work with the libraries, right? Private endpoints and dedicated endpoints. If you want to specifically do that, you can use it. But what we are doing here is enabling it. Okay, let me show you. Access keys I will select, and I'm trying to give admin user. So here it is disabled. I will enable this. When you enable this, you will get these keys. Okay, so I will just copy these keys and save them in the container registry. Okay, I'll just ensure that these things are recorded. Everything. I'm basically taking the registry name, the login server, the username, and two types of passwords that we have, password and password2. These things can be regenerated. If you feel that these registry passwords are compromised, then you might want to recreate this registry username, passwords as the keys, right? So you can just click on regenerate and the password will be. So here you can see, right? Upgrade to premium SKU to enable firewalls, private endpoints and dedicated endpoints. You can also try it, manage. I'm basically using this basic. I'll update that into your standard, or you might want to go back to your right, basic as well. Okay, so this way you can try and play around with your networking. You might want to upgrade to premium SKU also, right? This one, if you basically update it to premium, then you'll be able to manage a lot of things. Okay, so I'm not saving it. I'll just discard it. Come back. All right, next. The next step that we will have to do is with respect to registering the Docker image that we have with this Azure container registry. So here I will have to try and check the images and check the images. I have this image, right? Already that image is there. Let me go to that folder where we have this service. Yeah, this is the folder where we have the right software. And let me just once again check the images that we have. First thing is we need to connect to the container registry, right? And to do that, we basically have the login command. Yeah, this is the login command, right? So let us log in. So it is asking for the username password. I did not give the username password. So I'll say CAS SVM is the username. For the password, I will come here and I will take this password which we have saved. Login successful. All right. So once the login is done, right, this is the function. You can basically tag, right? We can tag the image that we have. Okay, so for tagging, we basically use this command, Docker tag the package name and then your container registry. So that command will be there here, Docker tag part2, and I'm giving the container registry, and we can give any name basically. This is the Docker image in container registry. Having this command, giving this command. Done. Now you can see Docker images. You will have this another image replicated, and this image is replicated to your container registry. We can check that here. Okay, so your repositories, if I click, that's not come. Okay, this is that. Strange, it's not showing. Probably it will take some time to reflect here, as it's otherwise it should basically come. Okay? Yeah, we'll wait for that to anyways take it time to pop up. Okay, so this image which is registered, now we will try and push it so that this container becomes active in our repository. So docker push is the command, and the container that we have created, this is the Docker image that we have created, right? So let us run this so that the container will get created. Docker push. Okay, that's the command, docker push, the image name. So this is now getting pushed into your container registry. Okay, we'll wait for this to complete, and after this, you will be able to see the details in your container registry. Okay. Next is we need to create Kubernetes cluster. Okay, these commands are placed here. Creating Kubernetes cluster, you can interchange that. Okay, so add this that way. I'll just keep it handy, keep it ready. Still working on. It will take another probably 5 minutes or so to deploy the entire application. Once this registry is basically having the Docker container created, that Docker container can be registered through Kubernetes cluster. We'll just wait for this to complete. We're almost there. Pushed. So once everything is pushed, you will basically see something like this. Right? Once it is pushed, you will see something like this. Yeah, done. So this is basically the container registry. Now let us see if it is reflecting here. Yeah, see, this is the repository that we have created, right? This is the latest one that we see, right? So we have successfully mapped a local Docker image into the container registry of Azure Service. Now we will try and create our Kubernetes service. Again, this Kubernetes service can be implemented directly from this page, from a front end. Here we can basically use this service. I'll go back to the home, and then you can see this Kubernetes service here, right? You can also search. If you don't see that, you can search for Kubernetes services like this. So this is the Kubernetes service. The service is getting created in the backend. It's running. This will again probably take a little while, like 5 minutes or so, to bring up the Kubernetes service. Now, once this is up and running, we will need to basically register it again with respect to the credentials. We will have to map it, accessing the resources, right? So we will try to get the AKS credentials. You just run it. This is the cluster name, Kubernetes cluster name, right? And then we are trying to say get credentials. And this is from a resource group. This resource group is like a standard, right? It doesn't change. This resource group will be standard. And for this Kubernetes cluster, you can define how many nodes you might want to actually create. Node count can be 10 as well. That means from 1 to 10, you can use as many as, right, 10 nodes. If you have a lot of, let's say, parallel users, concurrent users who are trying to use the functionality of your machine learning services, then load balancing is automatically done by this service. And the load is distributed to 10 different nodes. These are like mirror images. And if any one of the node is crashed out, the other nodes will anyways take the load, right? So fail-safe high availability scenario is also implemented by this Kubernetes cluster. So it's running. And once these services are developed, right? Once your cluster is ready, once it is completed, then we will register, get the credentials, and post that. All we are doing is implementing this YAML file. The YAML file contains the API that you are trying to call it. This would be your deployment. Right, let me show you the file there. Okay, this is the YAML file. Your YAML file templates will be readily available. You can just take the template and then try to deploy your application. So your application would be called as, in the backend, it is cars deploy. And you're basically doing the deployment. This is the action. You can also have replicas. 3 replications is what you are maintaining. The app in the backend is basically called as cars. And the container that you're going to create is called as cars image, which is from this image that we have created. And we are exposing the endpoint to the port number 5000. And here, the service that we are going to give from a Kubernetes application perspective is called as cars MLR-service. And you're saying it's also have load balance if you have multiple nodes and if you want to have the load balanced from a performance perspective, then you can also say this is a load balancing implementation. And port number here, anyways, you have exposed, you're mentioning that. Right? And the application that you're basically developing is called as cars. So that application will be active in this particular service called cars MLR-service. So this is Kubernetes cluster created. This is the entire cluster that is getting created. Now we will try and register the application here, right? So this is the credentials. We're trying to get the credentials here. That merged. Now comes the implementation of your Docker. Okay, so to do this, we basically are saying kubectl apply this command. So kubectl is the Kubernetes command where we are applying our solution here. And then I'll say enter. Okay, deployed, that's all. Job done. You will be able to see your pods. You can just say get pods, kubectl, get pods. So these are the pods which are active, up and running. You can also say services. This is the service that we have deployed. And you'll have to wait for this external IP and the port number. Right? So this is how you would be deploying your solution. And right, once this is done, you will be able to get the external IP. You'll have to wait for the external IP. Once it is up and running, you will basically be using the portal, the URL for getting your end user interface. So I'll try to show you. Hopefully, I'll just copy this. And let's see. Oops. We'll take the URL, right? And then we will wait for that to launch. Okay. All right, just wait for it to work out. Or we can just, right, just wait for it. Yeah. So you have the URL, and this is how you can try and see your application. Submit, you get the result. So this is basically how we do the deployment for your application in the Azure services. Yeah.